Hey everyone, welcome back to the channel. For a long time, the AI conversation has been dominated by flashy model launches, massive training runs, and trillion-parameter bragging rights. But today's video is about something quieter and arguably far more important. It's about what happens after the model is trained. It's about inference, and it's about Microsoft making one of its most consequential infrastructure moves yet with a new chip called Maia 200. Microsoft just announced Maia 200, its latest in-house AI accelerator, and this isn't a research project or a future promise. This chip is already being deployed inside Microsoft's data centers, already running real workloads, and already powering some of the most demanding AI systems the company operates today. Maia 200 is built specifically for AI inference, meaning the part of AI that actually generates tokens, answers questions, runs agents, and applies intelligence to real-world tasks. That distinction matters more than ever. Training large models still gets the headlines, but inference is where the money goes. As AI products mature and scale, inference costs quickly become one of the biggest operational expenses. Every prompt, every response, every generated token adds up. That's why companies across the industry are racing to optimize inference, and it's why Microsoft built Maia 200. Maia 200 is the successor to the Maia 100, which Microsoft released back in 2023. At the time, Microsoft was cautious about direct comparisons with competitors. This time, it's doing the opposite. Maia 200 is very explicitly positioned to go head-to-head with Amazon's Trainium and Google's TPU. Under the hood, Maia 200 is fabricated on TSMC's cutting-edge 3nm process. Each chip contains well over 100 billion transistors, with some disclosures putting that number closer to 140 billion. This is serious silicon. The chip is designed to excel at low-precision compute, which has become critical for modern AI inference. Maia 200 delivers more than 10 petaflops of performance in 4-bit precision known as FP4 and around 5 petaflops in 8-bit precision or FP8, all within a 750-watt system-on-chip power envelope. To put that into perspective, petaflops are the same unit used to measure supercomputers. The most powerful supercomputers in the world operate in the thousands of petaflops range. Maia 200 isn't meant to be a standalone supercomputer, but for inference workloads at scale, these numbers are massive. Microsoft says that in practical terms, a single Maia 200 node can effortlessly run today's largest AI models, with plenty of headroom for even bigger models in the future. That statement isn't just marketing. Microsoft is already using Maia 200 to host OpenAI's GPT 5.2 models for Microsoft Foundry and Microsoft 365 Copilot. The company's superintelligence team is also using Maia 200 for synthetic data generation and reinforcement learning to improve next-generation in-house models. One of the most striking claims Microsoft makes is about efficiency. According to Scott Guthrie, Executive Vice President of Microsoft's Cloud and AI division, Maia 200 delivers 30% better performance per dollar than the latest generation hardware currently deployed in Microsoft's fleet. That matters enormously at cloud scale. A 30% improvement per dollar compounds across thousands of accelerators, racks, and data centers. Microsoft is also very clear about how Maia 200 stacks up against competitors. The company says Maia 200 delivers 3 times the FP4 performance of third-generation Amazon Trainium chips, and FP8 performance that exceeds Google's 7th-generation TPU. This is a much more aggressive stance than Microsoft took with Maia 100, and it signals how confident the company is in this design. But raw compute isn't the whole story. One of the biggest bottlenecks in AI inference isn't computation, it's data movement. Feeding massive models efficiently is just as important as having fast tensor cores. Maia 200 addresses this, with a redesigned memory subsystem that includes 216 gigabytes of HBM3E memory delivering 7 terabytes per second of bandwidth, along with 272 megabytes of on-chip SRAM. There's also a specialized DMA engine and a custom network-on-chip fabric designed specifically to keep data flowing and minimize stalls. At the systems level, Maia 200 introduces a novel two-tier scale-up network architecture built entirely on standard Ethernet. Instead of relying on proprietary interconnects, Microsoft designed a custom transport layer and tightly integrated network interface that delivers predictable, high-performance collective operations across clusters of up to 6,144 accelerators. Each Maia accelerator exposes 2.8 terabytes per second of bidirectional scale-up bandwidth. Within a tray, 4 Maia accelerators are fully connected with direct non-switched links, keeping high-bandwidth communication local and efficient. The same communication protocols are used across trays, racks, and clusters, reducing network hops and simplifying programming while maintaining consistent performance at scale. This unified fabric is a big deal. It reduces stranded capacity, improves utilization, and lowers total cost of ownership across Azure's global fleet. It also reflects a broader shift in how hyperscalers think about AI infrastructure. The chip, the network, the software, and the data center are all designed together as one system. Microsoft leaned heavily into that end-to-end approach during Maia 200's development. A sophisticated pre-silicon environment was used to model large language model computation and communication patterns with high fidelity. That allowed Microsoft to co-design silicon, networking, and system software long before the first chip was manufactured. The payoff was speed. AI models were running on Maia 200 within days of the first packaged silicon arriving. Time from first silicon to first data center rack deployment was reduced to less than half compared to similar AI infrastructure programs. That kind of execution speed matters when AI demand is growing as fast as it is. Maia 200 is currently deployed in Microsoft's U.S. Central Data Center region near Des Moines, Iowa, with the U.S. West 3 region near Phoenix, Arizona coming next. More regions are planned to follow. The chip integrates natively with Azure's control plane, providing security, telemetry, diagnostics, and management at both the chip and rack level. Microsoft also built second-generation closed-loop liquid cooling systems to handle the thermal demands of dense inference workloads. On the software side, Microsoft is previewing the Maia 200 software development kit to developers, academics, AI labs, and open-source contributors. The SDK includes PyTorch integration, a Triton compiler, an optimized kernel library, access to Maia's low-level programming language, and even a simulator and cost calculator to help teams optimize workloads earlier in the development lifecycle. This openness is notable. While Maia chips have so far been used primarily inside Microsoft's own infrastructure, the company has clearly signaled that wider customer availability is coming. That means developers and enterprises using Azure could eventually tap into Maia 200-backed inference directly, benefiting from improved throughput, lower latency, and better performance per dollar. Zooming out, Maia 200 is part of a much larger industry trend. Tech giants are increasingly designing their own chips to reduce dependency on NVIDIA. Google has its TPUs, which aren't sold directly but are offered as compute through Google Cloud. Amazon has Trainium, with its latest Trainium 3 launched in December and Trainium 4 already in development, including integration with NVIDIA's NVLink 6 and MGX rack architecture. Inference is the pressure point driving all of this. As AI systems move from demos to products, the economics change. It's no longer about how fast you can train once. It's about how efficiently you can serve billions of requests, power agents, and generate tokens day after day without blowing up costs or energy budgets. Maia 200 is Microsoft's answer to that reality. It's not designed to replace NVIDIA GPUs entirely. Instead, it offloads specific inference workloads, reducing overall hardware cost while giving Microsoft more control over its AI destiny. For end users, this won't show up as a new chip you can buy. Maia 200 lives in data centers, not laptops, but its impact will still be felt. Faster Copilot responses, better throughput for Azure OpenAI users, improved performance for large-scale research workloads, and more headroom for increasingly capable AI systems. For developers, scientists, and enterprises, Maia 200 represents a shift toward more efficient, inference-optimized infrastructure. It could accelerate work in areas like weather modeling, biological and chemical research, and large-scale enterprise automation. And for the broader AI landscape, Maia 200 signals something important. The era of large-scale AI is no longer defined solely by model size. It's defined by infrastructure, by who can deliver intelligence reliably, efficiently, and at scale. Microsoft is betting that owning more of that stack, from silicon to software to data center, is the way forward. Maia 200 is a major step in that direction. Thanks for watching, this is AI Tides, and I'll see you in the next one.